Let's talk about parabolas. Let me first introduce what parabolas are, and then we will start looking at the equations of parabolas and graphs and other things. We're going to talk about two types of parabolas. I like to talk about up or down parabolas. Now, parabolas, an up parabola looks sort of like a U, although it sort of spreads out as it goes up. So this is an up parabola, it opens up. Down parabola would look like this. So we have what we call up or down parabolas, either opens up or opens down. But then we also will have what we call left and right parabolas. And sort of it's where the parabola almost, I think of it as like sits on its side. So it looks like this. And because it opens up to the right, we call this a right parabola. And then we can also have a parabola like this, which opens up to the left. So there are really four kinds of parabolas we're going to be looking at. Now the reason we break them up into up and down, left and right is because we have what's called a standard equation. We have a standard equation for up and down parabolas, and we have a standard equation for the left and right parabolas. So let me go ahead and write that here now. Of course, a lot of this won't make any sense, but we will go over this. For up and down parabolas, the standard equation is 4p times, in parentheses, y minus k equals x minus h squared, in parentheses. Now really, we have our x and y here, which are always going to be there, and that's our normal x and y when we have equations that we graph. It's this p and the k and the h are the unique things about parabolas, which we have to explain what those are and how to determine those. So this is a standard equation for an up or down parabola. Now what's interesting is for left and right, the standard equation looks very similar, except just the stuff inside the parentheses is swapped. In other words, for left and right, I also have 4p, but inside the parentheses, instead of y minus k, I have the x minus h. And then on the right-hand side, instead of x minus h, it's the y minus k squared. So these two equations look very similar. It's just the two parentheses are sort of swapped. Now the easiest thing to do is, well, let me say this first, and then the easiest thing is to do some examples, and then it'll make a lot more sense. As it turns out, when you have a parabola, for an up parabola, the lowest point here, sort of the bottom of the parabola, that point has a special name. That point is called the vertex. Now, if you have a down parabola, the vertex is actually this highest point. Actually, we call that a maximum. The minimum of this graph is the vertex, the lowest point. For a down parabola, that's a vertex. And then for left and right, hopefully it's obvious that here's the vertex for a right parabola and a vertex for a left parabola. Now, as it turns out, when we look at these standard equations, the vertex is a point. As it turns out, that point is going to be hk. So when we start looking at equations, if I figure out what h is and I figure out what k is, then those two numbers, I can find the actual point, the x and the y. This is an ordered pair. This vertex is a point on my graph, and I can find the vertex. So you notice we have h, k, and p. So really, if we find the vertex and we find p, then we have everything we really need in terms of figuring out these parabolas. So let's, as our first sort of exercise and as a way to explain what all this stuff means, let me just take an equation of a parabola, and then I'll tell you all the things we want to do with it. So here's an equation of a parabola. 8 times in parentheses y minus 1 equals x minus 2 in parentheses squared. All right, so you're given this equation, it's your parabola, and here are the kinds of questions you're going to be asked in the homework and even on the test. First, they're going to ask you to find or to determine the following things. And let me list these, and then I'll explain what these actually are. They're going to ask you to find the vertex. Then they're going to ask you to find what's called the focus. The vertex is a point on your graph. The focus is going to be a point on the graph. Then there's this thing called the directrix, which is actually going to be a line. So they typically will give you an equation of a parabola. They will say, find the vertex, find the focus, find the directrix. And then they'll say, lastly, and then they finally want you to graph the parabola. And the idea is once you determine these things, we can go and then plot the parabola without any problem. Now let me go ahead. What I like to do is let me try and list the steps you would go through to solve a problem like this. And as I list the steps, then I will go ahead and try and work through this problem. So let me, hopefully on the left, I can squeeze in the steps. And then on the right, I can actually do the work. So sometimes when you're first learning how to do something in math, it's best to learn the steps to go through. And then once you do it a few times, you just sort of get to know it. So let me write the equation up here again we're going to work with. So here's the equation we're given. And here's the things they're going to ask us to do. Find the vertex, find the focus, find the directrix, and then graph the parabola. And as I go through this, you'll begin to understand what all those things mean. So if you're given an equation of a parabola and asked to do all this stuff, the very first thing you do is put the equation in standard form. What does that mean? That means you go back. Earlier I gave you the two standard equations. I guess the key thing I think about is, you notice in both these equations you have a parenthesis that gets squared and a parenthesis with no exponent. And the parenthesis with no exponent has this 4p in front, which this whole thing is going to end up being a number in a real equation. So basically you have the squared parenthesis by itself on one side for both these equations. So that's the main thing I think about when I sort of say put it in standard form. Now I can look and right away determine what kind of parabola I have. Because look, here, the parenthesis with the x is squared. So when I look at my two standard equations, I'm going to go find the equation where the x parenthesis is a squared one. And it's this one here, which in a few minutes, I'm going to determine I have an up or down parabola. I'm going to go ahead and let's copy down the standard equation over here so we can compare it to the equation we're given. So the standard equation needs to look like this. So this is a standard equation where you have the x parenthesis is the squared one. And now I need to compare. Here's the equation I'm given. The key thing is I want the x sort of parenthesis that's squared to be by itself, no numbers in front of it. And as it turns out, it looks like the equation they gave me is already in standard form. Because you notice I have x minus 2 quantity squared with no coefficient. Over here, I have y minus 1 with a coefficient 8 in front. So the key thing is I have my squared parenthesis by itself, no numbers in front of it. So I'm already in standard form. Now the next thing I do, which I've already done, you should be able to right away determine what kind of parabola I'm working with. Is it an up or down or a left or a right? Now this is something you just have to sort of memorize or learn or remember. And that's when you have the x parenthesis squared, that is an up or down parabola. I don't know which yet, but it's going to be either up or down. Because once again, for an up or down parabola, this is a standard equation. And the equation that we were given for this problem is in this form. So I've determined it's up or down. Now I can actually I'm just going to write narrow down further, and I'll explain what this means. For step 2, I've already determined if it's up or down or left or right. Step 3 will be go ahead and actually determine what kind of parabola you have. So in my case, I know it's an up or down, but I want to actually determine, is it an up parabola? Does it open up or does it open down? And I can do that very easily. And here's the way you do it. Let me go over here and explain this quickly. So say you have an up or down parabola, and here's the equation, standard equation for an up or down parabola. The thing that determines whether it's up or down is this coefficient. It's going to be a number in an actual equation. For instance, so in our equation, it's 8, right? Whatever is in front of the y parenthesis, we call it 4p in the equation, but in our actual equation, it's the number 8. So this 4p is going to be some kind of number. And here's what's interesting. If that number happens to be a positive number, then we know it's an up parabola, opens up. If it's a negative number, it opens down. So it's really very simple. So for instance, in our problem, as soon as I put it in standard form, I look at the number in front of my y parenthesis and I simply say, is it a positive or negative number? Since it's a positive number, I know this is going to be an up parabola. This parabola opens up. Now, sometimes if you have here's a way that I remember, whether it's an up or down. I think of up as positive. I think of what does a positive person do? Positive person smiles. What does a negative person do? A negative person frowns. Smile is like, you know, it's like a U, it opens up. That's positive. A frown is negative. So once I see up here, I have a positive number. I think, oh, positive, like a positive person smiles. The parabola opens up. Now, just let me say here, if you have a left or right, I won't go into all the details, but a left parabola, the number is negative, and a right parabola, it's positive. So in other words, for a left and right parabola, the Shannon equation looks like this. If that number is negative, it's a left parabola. If it's positive, it's a right parabola. And we'll see some examples of that later on. So bottom line is, once we get the equation in standard form, first thing we do is we figure out actually what kind of parabola we have. So the second, third step, pretty easy. So for our example, we have an up parabola. So sometimes I even go over here and I just remind myself, I just draw a little sign here just to form in my mind what my parabola should look like when I'm done. Now the fourth step. We're going to find the vertex. And once again, remember what the vertex, so we have an up parabola. So in our case, I'm going to go find this point at the very bottom of the parabola. Sometimes people call this a minimum because it's the smallest point on the graph, but for now we'll call it the vertex. Vertex is very easy to find. Let me write down here so we can see it once again. Our equation. Well, let me just show it up here. I think I wrote this earlier, but the vertex is a point, and it's actually the point HK. So what we do is we go to our equation, and we compare it to the standard equation, and we figure out what the H is and what the K is. So hopefully when you look at this, it's pretty obvious to tell, right? Standard equation is x minus h, and we have x minus 2. So what is h? Obviously h should be 2, and over here y minus k and y minus 1. Obviously k should be 1, and h should be 2. So right away, fairly easily, I was able to determine the vertex is 1, 2. Up, see, I made a mistake. Good thing I checked my notes. HK 2, 1. So this is H, this is K. Now, a lot of times what I do, these problems, as I learn this information, I will go ahead and start working on my graph. Every time I learn something, I'll go to my graph and include that. So let me go get a new sheet of paper and we'll start creating this graph. So let me just do a freehand. I'll try and create like a X and Y coordinate system. And you just have to try and make sure you have enough room for everything. So let's just go maybe 1, 2, 3, 4, 5. So let's plot the vertex 2, 1, x2, y1 is right here. And I'll put a little V there just so I know that's the vertex. So basically, I know it's going to be probably some kind of parabola. Since it opens up, it's going to do something like this. So our fourth step was to find the vertex. Now the next thing that's key determine P, right? If you go back and look at our standard equation, you see this P here. I said earlier, in the standard equations, you've got your X and your Y, which are always there. And then you got H, K, and P. And the H, K, and P are going to be numbers. Let's figure out what those are. We've already figured out what H and K is for our problem. Now I need to determine what does P equal. Hopefully you can see 4P equals whatever number is in front of this parenthesis here. 4P equals 8, right? Very simple. 4P equals 8, which means P has to be 2. All right, we don't even have a name for P. We just call it P, but P is very important because P, once we know P, P allows us to find the focus. P allows us to determine the directrix. And really, P allows us to create the graph of the parabola. So doing this kind of problem, it's really 2 steps. You find the vertex and you find P, then you've really got everything you need to finish the problem. So now that we know P is 2, let's talk about what these things are: the focus, the directrix, and then of course graphing it. So let's talk about the focus. The key thing is, I think about the focus, it's a point, and I like to say it's the point inside the parabola. You know, if these are your parabolas, the focus for an up parabola is like right in here somewhere. The focus for a down parabola would be here. You know, right and left. Also these, the focus, what I call is inside the parabola. So how do we determine what the focus is? Well, it's very simple. Because I know, and this is where this is key, because I know my specific problem is an up parabola, I go from the vertex and I'm going to move up because I know the focus is inside the parabola. And since this is an up parabola, I'm going to move up an amount P. We just determined on the previous page that P is 2. So from my vertex, I move straight up 2. So that distance is P, and this ends up being my focus. So once you find the vertex and you find the value of P, and because we know what kind of parabola we have, we can go ahead and plot the focus. So actually, let me just keep track here. Let me rewrite. The vertex we decided was 2, 1. Now we know the focus, X is 2, but Y is 3. And we talk about the things they ask us They like to know the vertex, the focus, this directrix, and then to graph it. So what is this directrix? The directrix is a line, and the way you find the directrix, go back to our vertex, and we move the opposite direction of the focus, but we move also the same amount p. So it's almost like once you have your vertex, in this case, we moved up to find the focus up 2 because p is 2. This is inside the parabola. And then we also move down 2. And this point here is one of the points on the directrix. On these graphs, what we do then, you draw a dashed line. And this line is the, what's called the directrix. Now, on a graph, if you have a horizontal line, the equation for that horizontal line is always whatever the value of y is. You can see this horizontal line goes through y is -1. So for the directrix, we say the directrix is the line with the equation y = 1. So now I actually have determined the 3 things they asked for. They asked for the vertex, they asked for the focus, they asked for the directrix. And now the last thing is to graph it. And there's one more final step that allows us to graph it. What you do is, there's this thing called, I'm just going to give you the name, the latest rectum. That's some fancy Latin or Greek word. But the easy way to explain it is, once again, we're going to use this number p. And now what I'm going to do is, since I know this is a parabola that opens up, I go to my focus, and I'm going to move to the right and then to the left the distance 2p. So what's interesting is once you have the vertex, to find my focus, I moved up a distance p. And to find this directrix, I move down a distance p. But these next 2 points that help me graph, I'm going to move a distance 2p. So if p is 2, then 2p is going to be 4. So I go to my focus, and I'm going to move 4 to the right. 1, 2, 3, 4. And then 4 to the left. 1, 2, 3. Now these 2 points I'm plotting here are strictly to help me graph it. I don't even need to know the coordinates necessarily. But these 2 points are now 2 of the points on the parabola. So now I know the vertex is here, and here are 2 points on my parabola. So now I can sort of make a rough sketch of what this parabola is going to look like. So this is a pretty wide parabola, opens up slowly. But there's a rough sketch of the parabola. So now I've answered the question. Vertex, focus, directrix, and I've graphed it. I guess I didn't finish. Did I finish my steps here? If you want to have the steps. Once you determine P, then you can, once you know P, then if you remember, we were able to determine we were able to determine the focus and the directrix pretty easily by moving the distance P. And then last step, graph by, I'll just say using 2P, which we know what that means. So in summary, we'll do another example, but let's just summarize this. So you're given an equation, you're asked to find all this stuff. First step is you got to make sure the equation is in the standard form. The next two steps, basically, you're trying to find out what kind of parabola you have. Is it an up or a down or a left or a right? And then once you determine which kind of parabola you have, you compare your equation with the standard equation. And by doing that, you can pretty easily determine the vertex. And then you can figure out P. And once you know the vertex and P, you can find the focus, directrix, and then graph it. Now before we go on, let me talk about finding the vertex, because this can be a little tricky sometimes. Let me just give some examples of some other kinds of equations, and let me give you a little rule I use to find the vertex, because sometimes it can be a little confusing. So let me just do a little quick talk about finding vertexes, because it can sometimes confuse students. So for instance, the problem we just did, as an example, was this 8 times y minus 1 x minus 2 squared. And we determined this was the k, this was the h. And it was pretty simple because we knew the standard equation, everything sort of lined up nicely. By that I mean standard equation is y minus k. Our equation was y minus 1. Obviously, k is 1. Standard equation x minus h. Our equation was x minus 2. However, what if you had what if I just changed one thing about this equation? Instead of y minus 1, I have y plus 1. And now I say for this equation, what is the vertex? Now the key is when you compare this equation with the standard equation expects it to be y minus k. But if I look up here, I don't have a minus sign. I have an addition sign. So how is that going to impact? I mean, in this case, obviously the h is 2, but the k now I have to figure out, because it's not y minus k, I can figure out what it is. So here's what I do to keep from sort of becoming too confusing. This is a quick little rule that just always works. And I call it the rule of sort of opposites. Now, if you have another way that you want to figure out your vertex, that's fine, but this is the way I always teach, and it's pretty helpful. As soon as I get the equation in standard form, here's what I do. I know the k is in the y parenthesis. So I look at, in a sense, I look at the number, but I also include like the sign in front of it. So for k, I think of this as like a plus 1. And over here, the h part of it is a minus 2. It just always works out that when you do the vertex, the h and the k are quote unquote opposites of what I see up here. What does that mean? Well, for the h, I look up here and I see I've got a minus 2. The opposite of minus 2 is 2. So that's the x value of my vertex. I look for the k or the y value of the vertex. I've got a plus 1 here. The opposite would be minus 1. 2, negative 1 is the vertex for this equation. Let me do a couple. And in the same way, what if I applied that rule up here? When I was first given this problem, I look at the number plus the sign in front of it. So for the h, I've got minus 2. So the opposite of -2 is 2. And for the k, I've got -1. The opposite of -1 is 1. And that's why the vertex for this equation is 2, 1. How about if I'm given, let's do a left or right parabola. How about, so you're given this equation. Just for fun, what kind of parabola would we have here? Well, first of all, we see the y parentheses squared, and I know the standard form is 4p x minus h equals y minus k squared. So since the y part is squared, I know this is a left or right. And then what do? Once it's in the standard form, you look at the number in front of this parenthesis. Since it's negative, negative means like sort of goes in the negative x direction. It opens up to the left. And if I were actually going to do this problem, I would know I'd have a parabola that opens up to the left. All right, that's not really what I want to do here, but that's a good little practice. Let's find the vertex. For the h or the x part of the vertex, got a +3 here, so the opposite is -3. And for the k or the y part of the vertex, I've got a +5 here, which means the vertex is -3, -5. So that's a rule that I use that is just very simple to remember and always works. Sometimes it can get confusing when the equations are not minus or plus or whatever. That's a quick way. While I'm here, before I do another example, let me show you one more thing that can happen sometimes with vertices. And you'll see this in the next problem about what we're talking about, vertices. How about if I have a problem like this? Let me do this just for fun. This is an equation of a parabola. Looks way different than the stuff we have been doing. First of all, there's no parentheses. So I got a fraction here. Let's just start this problem. Let's just figure out what kind of parabola this is, and let's figure out what the vertex is, then we'll stop. That's all I want to go over for right now for this. So what kind of parabola would it be? First of all, I know I've got a y squared here, but I'm confused because even the y squared equation looks like this: 4p x minus h equals x minus or y minus k squared. I'm really thrown off because I don't have like any parentheses here, so this doesn't look alike. Well, that's true. There are no parentheses here. If we wanted to, and here's what we're going to do, we're going to, for now, sort of create parentheses to make it look more like this. But before I do that, before I even create the parentheses, let's fix one other problem. You notice whenever we try and get the standard equation of a parabola, we don't want any number in front of the squared variable. Well, here's 1/2 y squared. I don't think, or I know, I don't want this 1/2 here. I want to move it over here, so let's multiply both sides by 2. I know I always want to have my squared variable by itself. I don't want any numbers in front of it. So now, going back, where are these parentheses? This still looks very different than this. Well, I'm going to go in here and I'm going to sort of create parentheses. Let me just do it. Then once I do it, you'll see how it sort of makes sense. How about instead of x, I write x minus 0 in parentheses, right? X minus 0 is just x. So these two are the same, just looks different. And if I do the same thing over here, 2x equals y squared is the same thing as 2 times x minus 0 equals y minus 0 quantity squared. These are the same. Although now I have parentheses, and now it looks a little easier to understand because it sort of looks like my standard equation. So first of all, so what kind of parabola do we have? Well, this is the equation for the left or right parabola. So I know it's left or right. Which one is it? I look at this number here. Since it's a positive is like a right parabola. It opens up in the positive x direction. How about the vertex? Well, the whole idea of our little rule of opposites doesn't really matter because basically the vertex is 0, 0, which means the vertex is going to be at the origin. All right, so those are a little talk about finding the vertex for these problems, which hopefully you will not find too difficult. So now let me do one more example where we're given an equation of a parabola and we're asked to determine all the information. So this would be example 2. So here's the equation we're given. X equals -1/8 y squared. So we want to find the vertex, the focus, the directrix, and then make a rough sketch of the graph of this parabola. Okay, so this is sort of what I just talked about. At first glance, you don't see any parentheses. Now, when you do these problems, you probably will not do what I'm going to do now, but just because I'm teaching you, let's go and create some parentheses here. So based upon what I just showed you, x can become x minus 0, and y squared can become y minus 0 squared. Now right away, you're probably saying, you know what the vertex is, but before we do that, let's just get this equation in standard form. Let's go through the steps properly, right? So the first step is get it in standard form. And once again, you don't want any kind of number or coefficient in front of your squared parenthesis. So to move this -1/8, hopefully you all remember your algebra, I can multiply both sides by -8. So now it's in standard form, and just to remind you, standard form for this would be 4p x minus h equals y minus k squared. What kind of parabola is this going to be? This is a left or right parabola. And what is it? Well, what have I got here? What's my coefficient? It's a negative. Means it's going to open up to the left. Sometimes I just go ahead just to make it very clear in my mind, because when I get ready to figure out the focus and directrix, I need to know what kind of parabola I'm working with to do it correctly. So, vertex, right? Pretty straightforward. 0, 0, it's going to be at the origin. Let's figure out what p is. Well, 4p is -8. So p is -2. And really, when I start figuring out my focus and directrix, I don't really care that it's a -2. All I care about is the number. but the negative here is what caused it to be a left parabola. Now I've got my vertex and the value of P. I can go ahead and try and graph it. Let's go ahead. I don't think I have enough room on this page, so let's start on a new page, creating my graph. And normally the way you figure out your focus and your directrix is to go and start graphing it. Let's go ahead and make some marks here. So I know my vertex is at 0, 0, the origin. Now because I know P is -2, or really for now, I could think of P as 2 because all I care about is the distance or the number. And because I know it's a left opening parabola, so it's going to open up to the left. From the vertex, I can move a distance in the negative x direction of 2. I know that has to be the focus. And then I move a distance P, which is 2 in the opposite direction. And I know that has to be the directrix. And by the way, let me you might wonder what's the purpose of this directrix and stuff. Well, let me finish this problem, then I'll explain to you why the directrix is used sometimes. But let's keep track because they always like to ask you these questions. The focus or the vertex is 0, 0. Once I step off the focus, I realize it's -2, 0. In this case, my directrix is a vertical line. The equation of a vertical line is going to be x equals 2. Now, the last step is just to graph it, and to graph it, you always just figure out 2p. Since p is 2, 2p is 4, and in this case, once again, you go to your focus, and in this case, I'm going to move 4 up and 4 down, and that's going to give me 2 points on my parabola, which helps me to graph it. So if I'm right here to focus, and I move up 4, that's going to be a point on my parabola. And if I move down 4, that's another point on my parabola. And now I'm able to graph. Or at least make a rough sketch of this parabola. So there we go. Hopefully not too bad. Now, last thing before I stop this video, the way actually you create a parabola is if you look at a point on my parabola, now this, my graph might not be perfect, but if you choose a point on the parabola, and from that point, you move to your directrix at a perpendicular angle, which other means I draw sort of a line down to my directrix at a right angle. And then from that point, I go to my focus. The idea of a parabola is the distance from the focus to this point on the parabola, and from this point to the directrix. These are the same length. So if I were to go up here, I could look at this distance and this distance, and these two should be the same. So any point on my parabola, if I go from my point on the parabola to the focus, and if I go to my point to the directrix straight down at a right angle, these two distances are always the same. So that's the whole idea of how they create a parabola. All right, so in the next video, we'll do some other kinds of problems. And let me give you a sneak preview. So what we're gonna do in the next video is they're going to, sometimes they just give you a graph and they want you to come up with the equation of the parabola. So it's sort of the opposite. So far, they've given us the equation, and we've, in a sense, figured out the graph. Now they give us a graph, figure out the equation. And then the last thing is, sometimes they give you some information about the parabola, and then they want the equation. So they'll say, the vertex is this, the focus is this. You know, based upon that, what's the equation of that parabola? So these are the kinds of problems I'll go ahead and do in the next video. So we'll stop now, and then I'll pick this up in the next video.